I welcome you all for the new chapter required for the basis of foundation of understanding the mathematics for competitive examinations. The topic of this series is exponent and logarithmic functions basics. I will be taking up only the basics. Before starting the exponential and logarithmic functions, it will be uh, good to have understanding the meaning of an exponent. You must have seen your earlier classes multiple um repeated multiplications. That's like 3.3, 3 into 3 into 3 into 3 into 3. This is repeated multiplication of the same number. Repeated multiplication. You must have done in this your earlier classes. Here 3 is repeated 5 times. We can use exponential notation to write this product in compact form. What is that exponential notation? We just write this as 3 to the power 5. 3 is multiplies 5 times, that is taken to the exponent. This is called the base, and this is called the exponent. This we have already studied in your earlier classes. This is equal to 3 into 3 into 3 into 3 into 3 into 3. 3 multiplied 5 times. This is also called power of 3. Right. So what is the formal definition of an exponent? An exponent is used to indicate repeated multiplication. Used to indicate repeated multiplication. Repeated multiplication. It is how many times the base is used as a factor. If you remember this, then it is very simple to understand the meaning of an exponent. What is the meaning of the base and what is the meaning of an exponent? Right. This is the basic of exponent. Now here we are not dealing with exponent, we are dealing with exponent functions, not exponent. Right. What is that exponent function? As we have seen that exponent was of this form, x to the power 5 or 2 to the power 5. Right. Now if in place of this, and this was called exponent, if at the place of the exponent, we have a variable such form as below. Fx is equal to b की power x or y is equal to b की power x. That is, in the exponent position we have a variable, and such that b is greater than 0 and b not equal to 1, and x is a real number. Then fx is called exponential function. Exponential function. How it is different from exponent? That is, in place of exponent being some constant, here we have a variable in the place of a exponent. And b has some restrictions imposed on this value of b, that b should be greater than 0 and b cannot be 1, and x is a real number. That is our variable. The definition of b to the power x is called exponential function, right? This is the basic definition of a function, exponential function, b greater than 0 and b not equal to 1. Here I have plotted two exponential functions. The left one is 3 to the power x, and the right one is the 2 to the power x. This I have used the website desmos.com to plot these two functions. That is, I have plotted 3 to the power x and 2 to the power x. The plot was looking like this. Plot was looking like this. This is the plot of 2 to the power x, and this is the plot of 3 to the power x. As we can see, the plot of 3 power x is very rapidly going towards up infinity, and the plot of 2 to the power x is going to infinity with less speed as compared to 2 to the power x. This is a constant value where it cuts the y-axis, and this is called y-intercept. At x is equal to 0. This value is 1. You can see 3x to the power x, 2 to the power x at x is equal to 0 has value is equal to 1. So this intercept is 1. So this is how we have plotted two exponential functions. Now there is some more insight into the exponential functions. Suppose our function is b to the power x, b greater than 0. Now functions having value b lies between 0 and 1 and b greater than 1. This we have plotted. If b greater than 1, then all the graphs will be of this shape, which I have shown in the this graphic. However, if the b value is between 0 and 1, then I will show you what kind of graph it is. If our values of b are between 0 and 1, then the graph looks like this. For b greater than 1, our graph was looking like this. However, for between b0 and 1, the graph is looking like this. That is, now I explain, for b greater than 0, the exponential function is, the graph is like this. B greater than 1, sorry. For b less than b between 0 and 1, the graph of b is like this. B lies between 0 and 1. You can very well see that for some values of x, this graph will be mirror image of this. What are the properties of these graphs? The properties are, for b greater than 1, the value of fx is continuously increasing towards infinity, and for b lies between 0 and 1, the value of the exponential function is continuously decreasing. And decreasing from minus infinity to 0. Here the value is, this value is going towards plus infinity to 0. Here the value is going towards, y value is going towards plus infinity. As we increase x, this value is going towards 0. This is b less than 0 and 1. These are the two properties. So between these functions, function is continuously increasing function, and this is decreasing function. As we have explained in the chapter of inverse, this between 0 and 1, b greater than 1, continuous increasing implies one-to-one function. One function implies passes horizontal line test. So between these values, b to the power x has an inverse. Similarly, between 0 and 1, function is continuously decreasing. Second, one-to-one function. I will not give the definition of one-to-one. You can see the chapter of inverse. One-to-one and passes horizontal line test. So inverse exists. You can see also that it also fulfills the criteria of vertical line test. Both fulfills criteria of vertical line test. So inverse exists. As we have seen before, if we plot the function 3 to the power x and 2 to the power x, it looks like this. In some earlier chapter, I have defined the slope of a line, slope on a graph. Suppose we want to find the slope of both these graphs at this point, at where this is y is equal to 1, then we will find that slope of 2 to the power x at x is equal to 0 will be greater than 1. Sorry, it will be less than 1. And slope of 2 to the power x at x is equal to 0 will be greater than 1. This will be the slope line. I am drawing a slope line approximate at this graph and slope of this graph. So m is less than 1 and m is greater than 1. M is slope. So between these two graphs, these two graphs 2 to the power x and 3 to the power x, there must be some point in between at which slope of graph at x is equal to 0 becomes 1, equal to 1. The value of that point is p is equal to 2.71 something, and it is normally denoted by e, letter e, natural base e. It's why that is at e to the power x, that is the function e to the power x at x is equal to 0 will have a tangent whose slope will be equal to 1. It is a natural occurring irrational number, just like pi. Pi is a natural occurring irrational number. Why it is natural occurring? Because pi is related to the area of a circle if we have the radius of a circle. So it is a natural number. Similarly, e, which is having value 2.71 something is also a natural occurring irrational number. When we study calculus or population growth or many other factors in calculus, then the importance of e to the power x is very high. So mathematicians have defined this value e. We call it natural exponent, where slope is 1 at x is equal to 0. So please remember from where e has come and its importance. We will solve some problems.